So template user syntax simply requires this parameter type specification to complete some class declaration with specific data types. And the process of supplying specific data type to the template parameter type name is called template specialization. Basically, we say that during compile time, the compiler finds definition of our class, recognizes that it's parameterized by some sort of value right here, and we essentially replace this with integer. So the compiler will specialize this for an integer by replacing every occurrence of value type with an int, right? So value t becomes an int, and if you re-examine the syntax going back to the original version, it should be exactly the same as we started our conversation using just plain vanilla integer in our container, right? So this value type gets replaced by this type integer. If I want to change it to a double, I can change it like this. Okay, so now I can potentially do this 5.0, right, or 5.05, just to be able to recognize a fractional number. So I'll just save this version, build this version, and you see that now suddenly this container became a container of doubles. Let's try something different. We can also try, we could create maybe a container of strings. Right, so we declare container of strings. Let's try this container of strings somewhere as a second example right here. Just simply replace this with standard string. I will close this. Okay, and I will say container set. Okay, I will attempt to do container set and something like hello, which looks like a string at this stage. We'll see if this will be accepted by our compiler. And again, we just print, and this will be container of strings, like this, I guess. Container of strings, container of strings. Let's see how far we can go with this. Build. Okay, and interestingly, this compiles, so see if we can run this, and you can see that now we're printing both 50.05 and hello. I did not use new line on these statements. Maybe I need to add a new line for clarity at the end of our test outputs, which would be nice to have. So saving this and building it again and running it. So now you see that we now have a container that seems to be able to organize the storage by simply taking the data type that we like and plugging it in, like this string now will be replacing, in our second container example, will be replacing every occurrence of the value type, right? So standard string replaces value type. So this is an example of compiler really generating this template syntax for us. So examples of the syntax over here we already have seen in our example. I'm just using this container, right? So this container is a class which has some kind of storage example and very simple idea of setting and getting a value. So what else we have in this presentation? Well, let's basically add examples of syntax that involve using the template keyword and where else, just to observe where else we might need to use new syntax, which quickly becomes pretty cryptic. I would expect that you might need to watch these videos multiple times to essentially refresh your memory on where we got started and what else did we add to our code. So let's add a constructor, right? So normally you know that constructor would look like this. Let's just use default constructor, right? So this is perfectly good declaration of default constructor. But in a situation with the container class, I would recommend that we, whenever we use the name of the class, we can now explicitly add the fact that it's class which is parameterized by this value type, which will become an integer or double or string or something else. Okay, so this is an example of like using template parameter next to the name of the container. Now, how is it going to look like when we add a definition of this function? So what we would normally do, just copy this to our implementation file somewhere. I'm using just one file for now. And this is the signature of the constructor that basically we're trying to specify that this container is a constructor of the class template, and therefore we have to always provide the value type by adding it to signatures of our functions over this template prefix. It basically says at some point it will be known what value type is. It's a name of C++ type, like integer or some other type, and this will become container of an integer, and this will be the constructor of the container of an integer. Of course, then we remove the semicolon and we add function body. For now, I'll just keep this constructor without any modifications, just to prove the concept that this is the kind of syntax that we're going to be we could be able to use in the future. So let's just build it. It builds fine, really doesn't do anything, but we'll keep it at this stage. So right, so this gives us an idea how a constructor would look like inside a template class, parameterized by something right here. Arguments of the class type. Okay, let's copy and paste this constructor and also add a copy constructor to our class. Copy constructor will want to take a reference to another object of this type, so its signature becomes basically this. We want to say container constant reference to another object. Okay, so this is yet another occurrence of this type of syntax where we use the name of the class, which is a template class, with the parameter which is already being defined just when we when we're trying to construct an object of this type. The value will be specified, and suddenly this becomes very well known value. So let's take this signature and add the definition of this copy constructor. Okay, so the same way, the same approach, perhaps getting rid of the semicolon would be a good idea, right? So this we're gonna have to say that this is the name of the type, and this is the constructor of that specific type, and this type is a template. So we have to add all of this, and then suddenly this is all we need to do, right? So now we have a copy constructor that will do nothing, but at least let's give it a try to compile. So build Okay, so this builds fine. Let's just test our main function to make sure that nothing really changed in terms of the logic of our program. We're still printing a double value and the hello string right here. So this takes care of it. Let's think about, since we decided to add a constructor, let's see what should we try to maybe test with respect to copying one storage to another storage. So what the code might look like. The code might look like this. We say that we need a loop in which we will use perhaps size t, the unsigned integer type index, and this index will stay less than container size, right? So for each element within this container size, we will increment the index, and now we can write the code to copy individual elements. Of course, the default constructor makes a bit-by-bit copy, but I will add this constructor right now just to specify what it should do. So it should take the storage, right, and it should say storage of index. We're dealing with this primitive array of elements of some type, which is specified by value t. And we're going to say that it should equal storage index of another container, right? So storage of this other container that was given to us. So I think that's just the way we can provide the the logic for this copy constructor. So this is our copy constructor because it's a constructor which takes another object of the same type as a parameter. So that's by definition, this is a copy constructor. Again, I apologize that there's a little bit overwhelming stream of new syntax elements, but that's the whole point, that you spend extra time programming templates. But then look, we did a little bit of coding, maybe like 15-20 minutes of coding, but over here we're already starting to benefit from all of different things that are becoming available. So now we can, for instance, declare another container just like this. This will be also a container of a double, and say so this will be container number 2, and we can initialize it with the container. You know already that creation like this will invoke a copy constructor, because this will cause compiler to call the copy constructor, and container 2 will become a copy, and I assume that we can just continue using something like this and use container 2. So now the value, whatever value, 50.05, should be printed 2 times, but the second time it will be coming out of the second container, just to make sure that our copy constructor is doing what we're expecting it to do. I run the program. Wait a minute. So there was an initialized variable. Index. Yes, I forgot to initialize index to 0. Sorry about that. Let's build. Okay, and there you go. So now this comes from a second container, which is a copy of the first container, and I'm only displaying one specific element of that container. So this is our code so far. Okay, and you will be able to find example of every file as we move through the presentation about templates. You will be able to match the main function. I renamed the source files that match the slide numbers in the downloadable zip file with the source file samples for this presentation.